Good morning. We're approaching lunch, May the 5th. These are the coefficients of the series expansion of this product, and that comes from multiplying out the series expansion of each factor. So I just take one factor, 1 divided by this denominator. So it's 1 plus BP p to minus s bp squared p minus 2s, etc. That was not pretty. Then we just actually thought that AP was naught if P divided 2n. All right. Now we have to multiply these and see what we get. A typical term is BP to eth, P minus es, etc. And that gives 1 plus BP minus 2s minus 2AP times P to minus s. And we will have one more where 1 comes in. That was P. That's a 2s here. There we get it. So I'll do explicitly the one with P minus 2s. So from here we get P. The next one is 2 AP BP, and that's a minus. And the third one is BP squared. And then the generic term, I don't know which E we must use, so we just call this one, the first one use PE, that be PI minus PE minus 1, so that this guy, no, let's just be PE times 1, BPE minus 2 AP BPE minus 1 plus BPE minus 2 times P to minus, so that's ES. All of this has to be equal to unity. And that means that each of these terms must vanish. So we immediately get BP equals 2AP. That was this guy. And And the next one, oh, that's p squared, of course, here, p squared. I hope that's the formula we have here. E equals unity, that's right, and then minus 1. Oh yeah. No, what's that? Where did that come from? Oh, this is up here. Where does that 1 come from? That should be p, shouldn't it be p? Well, let's take that in a moment and then do the final one first. Yeah, that's, oops. Oh yeah, they have just written e plus 1 instead of. So it's just this guy, well, I don't understand where this unity comes from. Oh, that's times p minus 2s, that should be p, and then AP times BP and plus BP, so this should be P. When P is 1, then it should be P times, I'll just insert it. It's an AP, of course. B P to the first, this was number 2, minus P times 1. Oh, very well. And then they want this formula to be true because this just, the last term just vanishes when E is 0, right? So this holds in general. And then just that it's a number theoretic function that follows simply by unique factorization of integers into primes. We need to multiply all of these. One particular integer n, let's do black, if it's factored p to ep, that's factored then it's exactly the bp to ep that we must use. So, that's exactly what it says here. But this actually gives a very simple procedure for computing the series expansion of this guy, and that makes it possible for us to do the one-dimensional sum instead of a two-dimensional, as I did while studying this section. So that's very nice. And something very similar should hold with the curve that I worked on, because the form of the L function should be the same. I'll try, having done the exercises of this problem, to use this result and see if I can handle the curve I worked on was one of the many problems of section 5. And I used a two-dimensional sum, so we'll see afterwards if I can come through this and actually compute the L function, or the value at 1, using a one-dimensional sum.